Hello everyone, welcome back to my channel, and today we are going to start with our chapter number 1, and that is matrices. So this is a pretty important chapter in Sem-4 of your mathematics, and this chapter consists of 3 types which I am going to show you. So there are these types which I am going to explain you one by one, and then we will take sums on this, and I will also show you the weightage of each and every type. So the first subtopic in matrices that we have is eigenvalues and eigenvectors. You must have heard of these subtopics in your college before. So we are going to study about this in detail with examples. And the second type in this topic is Cayley-Hamilton theorem, or you can call it CHT. And the third topic or subtopic I would say that we have in matrices is diagonalization. It is also called as similarity of matrices. So now coming over to the weightage of these topics. So eigenvalues, you can expect one question for around 6 to 8 marks in your final semester exam. And from Cayley-Hamilton theorem, again you can expect one question for around 6 marks. And from diagonalization, you can expect again one question for 6 to 8 marks. So these are the weightage of the subtopics of matrices. So now we are going to start with type 1. So I am going to show you explain some concept to you, and then we will start with some basic sums. So we start with eigenvalues and eigenvectors. If you feel this video is slow or fast, you can of course toggle the playback speed in YouTube settings and let me know in the comment section below if any improvement is needed. So here I have written some concept regarding eigenvalues and eigenvectors. So this is the equation in which A is of course the matrix, and in exam you can either expect a 3 by 3 matrix or a 2 by 2 matrix. Only square matrix are expected, and 4 by 4 matrix will of course not come in exam. So in this equation, A is a matrix, lambda in here is the eigenvalue. So from value you can understand that can be an integer like 2, 5, 6. It can, depending upon the size of matrix, you will get the eigenvalues. Like if it is a 3 by 3 matrix, then you will get 3 eigenvalues. If it is a 2 by 2 matrix, then you will get 2 eigenvalues. Then x in here represents the eigenvector. So eigenvector is just a column matrix which consists of 3 integers, you can say. So this is eigenvector. So each eigenvalue will have its own eigenvector. So if there are 3 eigenvalues, then there will be 3 eigenvectors also. So from this equation, we can simplify this equation. So the equation above was Ax is equal to lambda x. So from this, if we take this lambda x to this side, we will get Ax minus lambda x is equal to 0. Then taking x common, sorry for the interruption, we can write a minus lambda I into x is equal to 0. So you can solve this equation to get your x. Also, we can take mod of the above equation like this one, and we can get a minus lambda I mod is equal to 0. Now why 0? Because in here, in this equation, if a minus lambda I into x is equal to 0, it means that either a minus lambda I is 0 or x is equal to 0. So in this case, we know as x is 0. So this becomes the equation. So from this we get that x is not equal to 0. That means a minus lambda I needs to be equal to 0. Okay, and this equation mod of a minus lambda I is equal to 0 is known as characteristic equation. This is a very important equation, you need to remember this. Now we might have studied about rank of a matrix in previous semester. So in a matrix, if we modify a matrix, then all its value changes, but the ranks always remains constant. So this is a very important point to note down. So now we are going to do some sums on this eigenvalue and finding out corresponding eigenvectors. So we'll start with first question. In this matrix A is given as values are 2 minus 2 3 1 1 1 1 3 minus 1. So this is a 3 by 3 matrix, and in this they have told to find the eigenvalues and eigenvectors. So this sum can come at around 6 to 8 marks in your paper. So we'll start solving this sum. So first they have told us to find out the eigenvalues. So as I have told you, to find the eigenvalues, we need to use this equation. So what does that equation say? A minus lambda I. So we are going to find out A minus lambda I. Okay, and A is given in the question, which is a matrix. So we will substitute in this matrix A 2 minus 2 3 1 1 1 1 3 minus 1. Minus lambda will remain as it is, and you must knowing this that I is a unit matrix which has values 1 0 0 0 1 0 0 0 1. So now if we take this lambda inside this, we will get 2 minus 2 3. This matrix will remain as it is, so just we'll write it down again, and now lambda will go inside, so that will become lambda 0 0 0 lambda 0 0 0 lambda. Now we are going to subtract these two matrices, and the final result of A minus lambda I will be 2 minus lambda. So this minus this, and minus 2 minus 0 will of course remain same, and in this 1 minus lambda, this will remain as it is, 1 3 minus 1 minus lambda. So this we got A minus lambda I. So this is also called as your characteristic matrix. So now we are going to find out the characteristic equation from this. So the characteristic equation, so to find out the characteristic equation, the formula is A minus lambda I mod is equal to 0. But to calculate this A minus lambda I, you need to find determinant of this matrix, this one. And it would be a pretty much difficult task to calculate the determinant of this matrix. So the shortcut that you need to remember to calculate it A minus lambda I of any 2 by 2 or 3 by 3 matrix is I am giving it below. So please note this down. This is important. This is a shortcut to find the characteristic equation. So for a 3 by 3 matrix, the shortcut to find your characteristic equation is lambda cube minus trace into lambda square plus sum of minors of diagonal elements into lambda minus your determinant. And for a 2 by 2 matrix, if you want to find out the characteristic equation, the formula is lambda square minus trace into lambda plus determinant of A. So now you might be confused about what is the meaning of trace of a matrix or how to calculate sum of minors or diagonal elements. So let's consider a matrix example 2 1 5 1 3 2 6 8 2. So to calculate the trace of this matrix, the trace is simply the sum of the diagonal elements of a matrix. So in this matrix, the trace would be 2 plus 3 plus 2, which will give us 7. So 7 will just substitute in here as it is a trace of matrix. So you get it? Trace means the sum of diagonal elements. Got it? Now coming over to sum of minors of diagonal elements. So in this matrix, sum of minors of diagonal elements. First of all, these are the diagonal elements. Do you get it? Let me just rub this out. So to calculate the sum of minors of each diagonal elements, just a minute, 2, 3 and 2. So the sum of minors of diagonal element 2 would be, you have to just ignore this column and this row, and then you have to find out determinant of this. So we'll get 3 to the 6, 6 minus 16, which will give us minus 10. Then to calculate, just a minute, let me look this. Now to calculate minor of this 3, we need to just ignore this row and this column, and we'll get 2 2s are 4 minus 6 5s are 30, which will give us 26. Again, to calculate minor of, let me just rub this out. Calculate minor of this 2, you need to just ignore this row and this column. So we'll get minus 3 2s are 6 minus 1. So 6 minus 1 will give us 5. So adding this will give us the sum of minors of diagonal elements. So this we need to substitute in here, and then you can calculate the value of lambda from this equation. In here, A is the determinant of the matrix which is given in the question, which is this one right here. So you can just find out the determinant of that matrix. You can also calculate this determinant in Calc. If you don't know how to do it, you can comment down me below and I'll try to make a video on that. So let's continue our question. So in our question, it was a 3 by 3 matrix. So we'll calculate the characteristic equation of this with the shortcut formula which I showed you just now. So the characteristic equation would be lambda cube minus trace. So trace of our matrix would be sum of diagonal elements, which will be 2 plus 1 minus 1. So it is giving out to be 2 lambda square plus sum of diagonal elements of matrix. So in this, the diagonal, as I told you how to calculate the minus of diagonal elements. So the minor of 2 would be 1 into minus 1 minus 3 into 1. So will give us minus 1 minus 3, which will give us minus 4. So this is the first minor. Just write it down right here. Now calculate minor of this middle one. That would be 2 into minus 1 minus 1 into 3, which will be minus 2 minus 3, which will give us minus 5. Putting it in here. Next minor of this would be 2 into 1 minus 1 into minus 2, which will give us 2 plus 2, which is 4 plus 4. And then we will find out the determinant of this matrix. So the determinant of the matrix will get 6, which is equal to 0. So simplifying this equation, we will get lambda cube minus 2 lambda square minus 5 lambda plus 6 equal to 0. So you can solve this equation in Calc and you can get the values of lambda as minus 2, 1, 3. So these are your eigenvalues. So as I told you, for a 3 by 3 matrix, you will get 3 eigenvalues and corresponding 3 eigenvectors. So now we are going to find out eigenvectors from these eigenvalues. So starting with case 1, when lambda is equal to minus 2. So we will consider the equation to find out the eigenvectors, which is a minus lambda I into x is equal to 0. So we'll just substitute in this a minus lambda I. So a minus lambda I is this equation. So in this equation we will substitute lambda is equal to our first eigenvalue which we have taken, that is minus 2. So keeping lambda as minus 2 here, in all these 3, we'll get this equation as 4 minus 2, 3, 1, 3, 1, 1, 3, 1. And x we can just write out like this, x1, x2 equal to 0. So you can write like this. So now we are going to find out the values of x3, x1, x2 and x3 with the help of Cramer's rule. You might have heard this rule, but you must have forgotten it. So I will just show you how to calculate x1, x2, x3 by Cramer's rule. So first you just need to write down x1 upon box is equal to minus x2 upon box is equal to x3 upon box. The important thing in this is to remember this minus sign. Many students forgot to write down this minus sign, and so inside this box we need to write down a 2 by 2 matrix. So the values which we will write are as follows. So the first thing you need to do is to just ignore this column right here. Ignore. And then as we have to find out value of x1, so we will just ignore the first row because x1 means first row, and then we will find out determinant of the remaining values, that is -2, 3, 3, 1. Similarly, for x2 we will ignore the second row, and then we will find out the determinant of 4, 3, 1, 1. Similarly, for x3 we will ignore the third row and calculate the determinant of 4 minus 2, 1, 3. So simplifying this, we get x1 upon determinant of this will be minus 11 minus x2, remember this minus, upon determinant of this would be minus 1 is equal to x3 upon determinant of this would be 14. So now we'll just write x1 is equal to, now we'll take all these values to the right side, so it will be minus 11 minus 1 and 40. So we actually did something wrong. In here there is no minus sign, so it is plus. So this x2's plus minus sign will be minus 1. So hence we get this first eigenvector. We will name it as x1. In some colleges they might tell you to do like keeping this equation is equal to t and then taking all these values to the right side and then comparing, but you can also write like this. This is a valid method. So we have got the first eigenvector. Now we will calculate the case 2. That is when lambda is equal to 1. This one. So the equation to find out eigenvector is same as before, a minus lambda I to x is equal to 0. We will just substitute, now lambda is 1, so we will again substitute lambda is equal to 1 in this equation. So we will get it this as 1 minus 2, 3, 1, 0, 1, 1, 3 minus 2, and x would be as it is x1, x2, x3 is equal to 0, 0, 0. Now again we will do this by Cramer's rule. So what we need to do in Cramer's rule? We need to just write x1 upon box minus x2 upon box and then x3 upon box. So in these values, first as I told you, we will ignore the last column or row. Then for x1 we will ignore first row, for x2 we will ignore second row, and then for x3 we will ignore third row. So I will just write directly like this, minus 2, 3, 0, 1, 1, 3, 1, 1, and 1 minus 2, 1, 0. So simplifying, finding out the determinant, we get minus 2 here, minus x2 upon minus 2, x3 upon 2. So the second eigenvector is taking all these values to the right side. We get minus 1, 1, 1. This minus sign will get cancelled, and you can see here that we can take 2 in here common. So if we get 3, 6, 12, like this, if we get the values of x1, x2 and x3, so we can just simplify it and directly write down the eigenvector as 1, 2 and 4. So this is also valid. So like that we have just taken 2 common, and then it becomes -1, 1 and 1.
तो इधर अंदर जाता हूँ, मेरा ज्यादा पॉसिबिलिटी है राइट होने का, तो मैं उसको बोलूँगा नहीं.
So now you can calculate the case 3 by yourself. That I will give you as a homework. In case 3, the lambda is, what was it? 3. So you can just substitute lambda is equal to 3 in the first equation. So this is actually, let me just clean this out. This is our first equation. So you can find out the case 3 by yourself. Now for calculating eigenvalue, this you will get only 2 marks. For case 1 eigenvector you will get 2 marks again. For case 2 you will get again 2, and case 3 again 2 marks. So that comes out to be 8 marks. So the important step in this question is that you must get this lambda correctly. If this lambda value gets wrong, then all of your eigenvectors will come out to be wrong. So how to check whether these eigenvalues are correct or not? So the best way to check if this is correct or not is to just find out the sum of these eigenvalues. It comes out to -2 plus 1 plus 3, which is 2, and this would be same as the trace of the matrix. So I'll just write down here, sum of eigenvalues will be equal to the trace of the matrix. So in here the sum gives out to be 2, which is our trace. So like eigenvalue comes out to be 4, 0 and -2, then also the sum will be 2. Then how it can be correct? So the second way to check if these eigenvalues are correct or not is to just find the product of these eigenvalues, and that would be equal to your determinant of the matrix, that is mod of A. So if we calculate the product of this, we get it at -2 into 1 into 3, which is -6, and if you check here, -6 is the determinant. So thus with these two methods we can just verify that our eigenvalues are correct or not. So got it? So in next video we'll solve another question, another type in which the eigenvalues would be repeated one. So here there are distinct values. In next video we'll check out if these values come out to be repeated, then what will be the answer or how to solve this question. So thank you everyone.